Howdy, this is your friendly neighborhood physics teacher here, and I'm going to do the first metric practice problems with you. So if you need a little help, I'm going to do them step by step. Now, giving you a heads up, your problems were scrambled. So if you're looking at your notes, you might have to figure out, okay, my number one won't be the same as your number one because they were scrambled from person to person. So the first one I'm going to do 56 kilograms, and we wanted that converted into milligrams. Now, there's a couple of different ways to do it. I'm going to do it the jumping method. Now, first time, like moving the decimal. I can't fully do a true jumping method because I don't have the stairwell picture for y'all, but you can follow along in your chicken duck. So a true jumping method is you would start at kilogram and you would jump down. And what you notice, if you count, you're going to jump 6 times by the time you get to milligrams. And that's how many times you're going to move. And since you're going down the stairwell, you're going to have to move it to the right. So you move it 6 times. Now, a way I can show you on here is looking at your exponents. The exponent that goes with kilo is 3, and that's where you're starting out. You're trying to get to milli, so that's a -3. Now, what you're going to do is you're going to subtract those two numbers. So you're going to do 3 minus a -3. What happens when you do a negative minus a negative? Yep, you get a positive. So that gets you 6. That gets you back to the 6. So we count the stairs, get 6. You check with the 3, you get 6. So now we're going to move it 6. You move the decimal 6 times. When you have a number and it doesn't show you where the decimal is, your decimal is always behind the very last number. So now we're going to jump 6 times. 1, 2, 3, 4, 5, 6. So that's where my decimal goes now. And we fill in zeros for where we jumped. Should add 6 zeros. 1, 2, 3, 4, 5, 6. And that is our new number. It's huge, huge, huge thing. 6. Now, is that the way scientists like it? I mean, that technically is in milligrams. Technically is. That's not the method or the way we like to present numbers here as a scientist. We like it in scientific notation. So scientific notation is when you have only one number that's not a 0 in front of the decimal. So we want the decimal to be there. That's what we want. And so we have to figure out how many times we have to move the decimal to get there. So we're going to move it 1, 2, 3, 4, 5, 6, 7. So we have to move it 7 times. So that's where the exponent comes in. Get 5.6 times 10 to the 7. Now we have to look at, is it positive or is it negative? Now, since we're going from a bigger number, this is a big number, to a smaller number, so we're going from a bigger number to a smaller number, it's going to end up being positive. So the 7 is positive. And that is our answer. So there we go. Now, if you like the purely exponent way, I'll do the next one that way. So the next problem I'm going to do is the 532 centiliters, and we want that to go into kiloliters. Now let's look at the exponent. Centi is a -2, so we're starting. Kilo is 3, and so we subtract where we started to where we're going to, and you get a -5. These are all exponents. So now we can do 532 times 10 to the negative 5. And yes, this is technically in kiloliters, but it's not in scientific notation. Remember, we want the exponent, we want the decimal to be only one behind a non-zero number. Our decimal is there. So we have to move it 2 times. So we're moving it 2 times. Again, remember, we're going from a big number to a small number, so therefore it's positive. So that 2 is positive. So what that means is, because we're moving, this is an exponent. So we're just going to add the 2 to the 5. So you get 5.32 times 10. And when you do negative 5 plus 2, you get a negative 3 kiloliters. And that is our answer. So now we're getting into the word problems. So the first word problem I'm going to do is the bike riding one. So Johnny, he rides his bike for, nope, not 3, looking at the wrong one, for 4 kilometers. Sally rides her bike for 3,000 meters. We want to know which one went further and how much further did that person go, and our answer has to be in kilometers. So let's go ahead and convert Sally's into kilometers. So let's look at, meters, the exponent for meters is 0. The exponent for kilo is 3, so we're going to subtract those two numbers, and you get a negative 3. So remember, when the decimal is not given, it's at the very end, and so we want to move it 3. Now remember, this is telling you, that negative is telling you move to the left. So we're going to move it 1, 2, 3 times. So our answer is 3 kilometers. So which one went further? John went further. And how much further did he go by? That's when you just subtract. Well, if John went 4 and Sally went 3, that means John went 1 kilometer longer than Sally. Now, again, that's technically not in scientific notation, so we want the decimal to be 1 behind a non-zero number. It's already like that. So how many times did we have to move the decimal? 0 times. There you go. So John went the furthest, and he went 1 kilometer longer than Sally. Next one, we're going to look at the peach problem, because y'all are such peaches. Sorry. So in the peach problem, it says a peach weighs, or I really should say the peach's mass. So the peach's mass is 65 grams. And we are going to buy 10 peaches. And it says that for every kilogram of peaches, we have to pay $5.50. So that's per kilogram. So that's per kilogram. So we're in grams, we need to get to kilograms. So grams is 0, exponent. Kilograms is 3, so we're going to subtract. So we get a negative 3. Remember the decimal, if it's not present, it's behind the number. And it tells us we're going to move to the left. So we're going to go 1, 2, 3. We're going to make sure we put a 0 where there's not a number. So it's 0.065, which if you think about numbers which make sense, because kilo is a bigger prefix than just gram. So if you have 65 grams, it makes sense that as you go up your stairwell, the number gets smaller, going to 0.065. As you go down your stairwell, the number is going to get bigger. So think about that. Up the stairwell, the number should get smaller. Down the stairwell, the number should get bigger. So that's how much one peach weighs. But we're buying 10. So we now need to multiply that by 10. Sit here, 65, So you get, I know it's been a long time since y'all have seen this. We have 3, so 3, dun dun da da. So we get 0.65 kilograms, and that is for 10 peaches. Now, how much is that going to be? You're just going to multiply those numbers together. So, and even if at this point in time you wanted to, just check, you didn't know if you needed to multiply or divide, think about it. So if you multiply 0.65, if you multiply those together, and I'm not going to do the long division again, you're going to get 357.5. In which you don't quite have a kilogram, so it makes sense that you're going to pay less. Let's say you're sitting here, you didn't know, you divided. Well, you're going to get more than 5, which doesn't make any sense because you don't quite have a kilogram. So you shouldn't be paying more than a kilogram. So even if you sit there and played with it, you weren't very sure, common sense should figure out that it should be 5.575. Now, think about money-wise. Can you have half of a cent? Oh no, so your answer is going to end up rounding up to $3.58. Now, I'm going to do a little sneak peek. So what we're going to do on Tuesday and Wednesday is dimensional analysis, or railroad tracks. And you could have done that on this one too. So you have $5.50, and it's per, so that's divide, kilogram. And you're trying to figure out what to do with this 0.65 kilograms. We want the dollars, we don't want the kilograms, so the kilograms need to cancel out. So you're going to put it on the top. So our kilograms cancel out, and you end up multiplying. And you end up getting the 3.58. So, little sneak peek there. Our last problem is Walt getting taller, and we want to know how tall he was a year ago. So Walt grew, he grows 10 centimeters a year. So for every year. So he grows 10 centimeters a year. Now, he is 1.6 meters tall. And we want to know how tall he was a year ago. Okay? And we want the answer to be in kilograms. So let's get these to be the same. So let's go from, we want 10 centimeters, and we want to get it into meters. So centimeters is, exponent is 2, meters is 0. You subtract those numbers, and you get a negative 2. So remember, negative means you're moving to the left. So you move it over 1, 2 times. So you get 0.1 meters. Now we want to know how tall he was a year ago. So if he grows 10 centimeters per year, so a year ago he would be 10 centimeters or 0.1 meters shorter. So we're just going to subtract. And you end up getting, he was 1.5 meters tall a year ago. But we want our answer to be in kilograms, so we have to convert, 5 meters. Again, so meters is in 0, kilometers is 3, so you get -3. Now, you can sit there and just move it. Remember, this is an exponent, so you can just take the 1.5 times 10 to -3. You have to make sure it's in scientific notation. Pretty much at a 0 right there. And it is. The reason it's already in scientific notation is because there's one number in front of the decimal. And there's your answer. So those are all the problems. If you still need help, please come in for tutoring. You do have an entrance ticket on Wednesday. So please make sure you know how to do this before Wednesday. Have a great day. Bye.